But I'm like, that noise.
Okay.
I didn't even hear.
Anyway, yeah, I didn't hear that either. Okay, so basically, because x minus c is less than c over 2, this is true. So let's just say since this, which is since 0 is less than absolute x minus c is less than c over 2. So you're just kind of giving the reason. Because of this, this is true, and because of this is true, which is all the basically the work that we did up there. Okay, and now you see where I'm going to go with this, right? I'm going to take this denominator, multiply through by it, right? So now absolute x minus c times absolute x plus c is less than epsilon, and so now you're basically back to your original inequality that you're trying to prove. So that's the end of the proof. So the trick to this, guys, when you have an x in what you want your delta to be, is to choose a preliminary delta. See, if we had, just choose a preliminary delta that kind of restricts the x in a nice way, like what we did right here. That's really what you want. If we had made this interval too big, then we might have had, for example, what if we made our interval so big that it included negative c? Well, if x could equal negative c, then we've got problems right here, as there's certain values of x for which it doesn't make sense. So it's just kind of convenient to make this interval half of c and work the proof from there. Okay, so that's the idea there. Let me think if there's anything else I need to say about that. I don't think so. I think that's pretty good. So I'm gonna let you guys think about the equal zero case is easy, because you just put 0 in here and here, and you just do it straight off. That's pretty simple. And then the less than 0 is also basically just a modification of this one, where you have to, so if c is over on this side, right, you're going to do a similar delta, but you just have to get your signs right, basically. But otherwise it works pretty much the same. I like this. We just get to practice problems. No new material. We reviewed the definition of limit of a function. We reviewed what an accumulation point is. We reviewed how to use that monotone convergence theorem to solve a problem. We reviewed limits at infinity. So it's kind of a nice set of examples to review all of that. I'm going to post these answers up in case you want to read them later. I'll also post the videos of this, and probably do this again next week if we've got 8 people here. That's not too bad. So, is it helpful?
It is.
Do that? Okay, good. Yay! I'm really glad to hear that. So what I will do, I'm going to stay for my office hours. I'm probably going to go sit down and rest my foot for a few minutes. But you guys can come on in if you want to talk about the homework or anything else from the notes or whatever. Or you can collaborate, hang out. I'll be here all evening, and we'll call it good.
We can do it.
Okay.
Thank you.
All right, you guys are welcome.
Thank you.
Yeah, you're very welcome. I'll go start loading up these videos.